Hello, and thank you for joining me today. My name is Anthony, and I'm the Chief Product and Operations Officer at Eggplant. So I'm going to start this presentation with two numbers from a recent Gartner survey, 86% and 18%. 86% is the percentage of testing teams today that feel like they're achieving their objectives. So that's pretty good. But only 18% of these same companies, these same testing teams, believes they're delivering their desired customer experience. Now, I have to say that the first time I looked at these numbers, I wasn't very surprised at all. You're probably not very surprised either. They kind of resonate with your day-to-day experience. But the more I thought about it, the more these numbers really started to bother me. First, it says that as an industry, we still don't really know how to make software that delights users, helps them achieve their objectives, and helps us achieve our desired outcomes. So that's not good. We don't know how to produce great software. We've been trying for a while. We need to get better. But second, and even worse, it says that testing teams don't even think that it's our job because we're meeting our objectives, but we're not delivering a great customer experience. So that says we don't think delivering a great customer experience is what we're all about. And that worries me because I'm not sure that test is going to be relevant in a digital world if it's not entirely focused on customer experience. I mean, just look at some of these statements from top analysts. 80% of companies rate CX as a top strategic objective now. 80% of CEOs believe they deliver a superior customer experience, but only 8% of their customers agree. Now, those numbers are sort of worryingly similar to the one on the previous slide. Maybe CEOs are looking at testing teams and saying, well, the testing team's all happy, the lights are green, we must be doing well. But actually, only 8% of them are delivering a customer experience that their customers are liking. And this is actually reinforced by a recent Forrester bit of research, which when we asked CEOs, what are your top priorities for testing? The number one was improving customer experience. So customer experience is becoming even more critical in a digital world. CEOs are looking to test to be focused on customer experience. Most testers I know want to be delivering a great customer experience, but we're not, and we don't seem to think it's our job. So what's going on here? Why aren't we focused on customer experience? So I talked to a large number of test teams, probably about 100 or 150 test teams around the world, and I asked them what they think the purpose of testing is. And you get some brilliant answers. Some are very funny, but the one I heard several times, and I think really explains this disconnect between 86% and 18%, was when people said, test is all about ensuring that the software works properly. And that helped because that made me think of verification and validation, and that helped me visualize a bit what I think is going on. So for those of you who don't remember verification and validation, let me take you on a bit of a trip back through time. A long time ago, testing always used to talk about verification and validation. Verification was, does the software, does the product comply with the specification? Is it right? Validation was, does anyone care? Is this delighting our users? Is this achieving its fundamental purpose? And that's what testing was all about. Testing was all about verification and validation. But something's happened over the last 10, maybe even 15 years, where we've redefined test to only be about verification, i.e. only about ensuring that the software works properly, where properly means that it complies with the specification. And actually we did a little better than that because we thought, you know what, maybe if we just say we're not going to do validation anymore, people might say, hey, that's not good, and be a bit concerned. So I have to say, we did a bit of a Jedi mind trick. We sort of flicked everything around, and we invented this mythical entity called the business, who is responsible for creating these absolutely perfect specifications that capture in detail everything that we need to do to delight customers. They can predict the desires of every single user we'll ever have in great detail. They encapsulate this in a specification. And what that means is as the test team, if we just do verification, if we make sure that the software complies with the specification, well, because these specifications are so perfect and represent exactly the customer experience we need, we've implicitly done validation. So over the last 10 to 15 years, testing's really just focused on verification, but we've constructed this setup, which means that implicitly we're doing validation. And that sounds great, right? I mean, it's quite compelling when you look at it on a slide like this and when I talk it through. Unfortunately, there's just one big problem with it. It doesn't work. It just doesn't work. And you can see that with the numbers, because this is what's going on with those two numbers I presented earlier. 86% of teams are saying our verification is good. We're achieving our verification objective. Our software is compliant with the specification. But only 18% of people believe we're doing validation correctly, that by getting this software to comply with the specification, we're delighting our users. So it's sort of worked in a way for testing teams, but it hasn't worked for companies producing software. It definitely hasn't worked for users. And I don't really think it's worked for individual testers, because deep down what we're all about is making great software that delights our users. By the way, if any of you still sort of think that you're just going to focus on unit testing explicitly, you guys have another level of magic going on here. You have a level of magic called architecture, where by making sure that all our individual units work correctly, that implicitly means the product as a whole is working correctly, and that means that we're delighting our users. So that's quite a stretch, and it may be why people who focus entirely on unit testing have even worse customer satisfaction. Right, so given that the setup I talked about earlier was pretty compelling, it made a lot of sense, why didn't it work? Why didn't it work? Well, I think in the majority of cases, there was simply never anyone assigned to actually do this role, be the business. I mean, whenever I go into teams, I hear the word the business a lot, and I always ask the question, who is the business? Who is this person? Can I meet them, please? And usually you end up with a response of, well, no, not really. That person doesn't exist, or it's kind of spread across these people. So the real problem is, in most cases, the business doesn't exist. I mean, I know we all have product managers or product owners, but creating a specification that covers everything that may impact user experience is just far beyond what a product manager or product owner would normally be expected to do. In fact, I think creating a specification that captures all the elements of customer experience, predicts the impact on all users, and of course does this within the timescales of an agile or a continuous delivery project is just simply an impossible task. So I definitely don't think people should just pour more and more money into getting people to fill this gap. So there is this huge gap in organizations today about how we're really going to ensure that the software we produce is not only correct, not only complies with the specification, but is actually going to delight users and drive business outcomes. And I think test should take responsibility for addressing this gap. We're the best placed people to address the gap. CEOs want us to do it. We want to do it. Let's do it. But of course, big question, how do we do it? Because, let's be honest, one of the reasons I think testing was redefined to focus only on verification is because no one really knew how to do validation. And it feels a bit subjective, it feels a bit difficult to measure. So we focused in on verification, which is a lot more concrete. But that's what this presentation is all about. It's all about a new approach to testing, which is transforming it to focus on improving customer experience and driving business outcomes rather than just focusing in on specification compliance. And we call this approach customer-driven testing. And the inspiration for how we address this gap and produce software that delights users came from spending time with the 18% of teams that are meeting the quality expectations of their users. I found one key thing that all these 18% of teams do that most other teams don't. And you can see it right on the slide here. All these teams had strong manual exploratory testing functions. This setup here is what they really had. Now that's super interesting, right? Why is manual exploratory testing, in some people's minds, this kind of vestige of the old world, helping teams deliver software in a digital world with better customer experience? And to answer that, let's just look at how manual exploratory testing works. So, manual exploratory testing, unlike specification-driven testing, starts with the set of all possible user journeys. You have this sort of infinite space of possible user journeys. You're not constrained by specification or maybe technology limitations of your automation framework. Every different user journey is in play. Then you get your best testers, like my tester here on the slide, the ones who understand the product, understand how customers use the product and what they're really trying to achieve. They understand the risky parts of the tech stack and the dev process. They know the feature that was rushed in at the last minute in the sprint. They know the developer who's new to the code base. They know the bit that wasn't quite tested properly or doesn't have very good coverage. So you get your best testers and they use all this knowledge to choose the user journeys they're going to test to maximize the user experience. And this phrase user experience is again really key. Whenever I spoke with the guys doing manual exploratory testing within these companies and I asked them how they decided which user journeys to select, which ones to test, they all talked first about user experience or customer experience. None of them started by talking about verification or the specification. Now, of course, they use the specification. That's a great input to them. It tells them what's changed, which is a good indicator of risk. And of course, they do need to cover that functionality. But the specification is very much an input to the manual exploratory testing process. It's not a goal. It's not a goal. The goal that everyone explained to me of exploratory testing was customer experience. Also note that all these testers looked not only at functionality, they also looked at performance and usability. They would say, ooh, this screen's taking a bit longer to load, or hey, that screen's really messy and non-intuitive. They're empowered to have an opinion beyond the specification because they're respected, because they have all this knowledge. So manual exploratory testing is how these teams are able to deliver an excellent customer experience because they focus on the user, not the specification, because they're leveraging that vast amount of knowledge to select the test cases, define the validations, and improve customer experience. They look at functionality, performance, and usability, and they start with that infinite universe of tests to choose from. So manual exploratory testing is currently the best approach we have for improving the customer experience of software. But unfortunately, there are also a couple of limitations. It's a very manual process, so it's expensive to scale in terms of people and time. And the reality is there's just a limited number of people in the world with these skills. There's not that many people in each organization who you'd really trust to have that opinion beyond the specification, who you know are going to choose the right test cases. So it's expensive to scale up manual exploratory testing, and it's also just very difficult in terms of skills supply. It is time consuming, and it's difficult to include it in a process that is truly continuous delivery. It's also a bit non-transparent. It's a bit qualitative rather than quantitative. It's hard to know when you've done enough manual exploratory testing on a release, which is why most people kind of put it in as, you know, we're going to do our formal testing and then we'll do some exploratory testing to do any additional goodness. It's hard to analyze manual exploratory testing in terms of what works well, continually improve. And all of this is just a bit uncomfortable when you're a digital business and your success depends on the quality of the customer experience you're delivering. So this was our inspiration. The question we had was, could we find a way to make manual exploratory testing more scalable, faster, and a bit more analytical and qualitative? And the answer, of course, is yes. Well, this would be a really bad presentation. And the key is really all the recent advances in AI, ML, and analytics technology. That's what's really unlocked it, at least for me. So here's what this new approach we like to call customer-driven testing looks like. At the center, we have a model of the application, which can be used to automatically execute any user journey through that application. This gives us that complete, almost infinite universe of test cases to choose from that you really need for exploratory testing. And these test cases include functionality, performance, and usability validations. And it's really model-based testing combined with AI and machine learning that have made this possible. Then we have an intelligent AI-powered test selection engine that decides which user journey to execute next. I think this is probably the most important bit in terms of emulating manual exploratory testers. This engine takes an input from a huge number of sources. It looks at the software development process, the code base, and the application itself to determine technical risks. It looks at the testing that's been done so far to see where bugs have been found. Critically, it also looks at what real users are doing today to understand the most common user journeys, which ones lead to conversions, i.e. which ones are the most important. So the selection engine has all this information about technical risk and customer value, and it's using this to decide what test to execute next. This is just totally different from how specification-driven testing works today. Now, testing, of course, it's not just about executing user journeys, it's also about deciding what failure looks like, which I think in an increasingly dynamic, especially in the Internet of Things type world, is becoming increasingly difficult. Now, obviously a crash or a button not doing anything is a failure, but there's lots of other behavior where a tester has to make a judgment call about whether something is a defect or not. So the approach also includes a second intelligent AI engine called the validation engine. And this is all about understanding how the technical aspects of the product, functionality, performance, and usability impact customer experience and conversions, and then using this to define what a failure looks like. So using customer behavior, customer reactions to define failure rather than expecting everything to be defined in a specification. So for example, in the retail world, the validation engine could determine that in production, if the load speed of a particular page goes over 2.4 seconds, sales reduce by 6%, and so if it ever sees that happening in pre-production, it'll flag it as a failure. It could also determine that if you use a 6-point font, or if you have a certain menu layout, it confuses people and they abandon your application. And so these would also be test failures. So the validation engine determines test failures by looking at the technical behaviors that impact users. Okay, so we have a central model that's capable of automatically generating user journeys. We have an intelligent engine to decide the next best user journey to test. And we have a second intelligent engine that decides what failure looks like in terms of functionality, performance, and usability. So this is pretty good. We basically have a setup that's starting to emulate what great manual exploratory testers do. But there's something missing. There is something missing from this picture. And I will quote Eric Siegel, who's actually the inventor of predictive analytics. And Eric said, "Art drives machine learning. Strategies designed in part by informal human creativity succeed in creating predictive models that perform well." So the thing that's missing from this picture is the human tester. Because what Eric's saying here is that on its own, this setup can perform pretty well. But when it has a human tester giving it hints, making hypotheses, and just generally kind of guiding it, it's truly amazing. I mean, and when I say guidance, I mean things like a human tester saying, look, I'm worried about what happens when I'm on a call and I receive a text message and maybe Bluetooth's on and it's sort of happening on older versions of Android. This is experience and intuition from the tester, which is extremely, in fact, it's impossible to replicate that level of intuition in machines today. But machines are great at going and exploring all the different options, looking at what the correlations might be in the data. They can do that much faster and much more systematically than a human. But it's really important to highlight that this new approach is all about augmenting existing manual exploratory testers to be more scalable, faster, and more analytical. We don't want to take people out of that equation. Testing went down that road. I think we lost about 10 years because of it. And I really don't want to stifle the new opportunities presented by these new technologies by getting into that people versus technology discussion. It's got to be about having great testers being augmented by great technology. So that's an overview of this new approach to testing, which we call customer-driven testing. And we call it that because fundamentally, like exploratory testing, it's focused on the user and the user experience rather than on the specification. I mean, if you picture this diagram I've got on the screen here, in terms of sort of old world testing, it would look very different. It'd all be driven from this magic specification, where here we've got it being driven from people on the left, the development team, the code, Jira, so the data from the process, and users, what they're doing, what they like, how they're behaving. But this is all very much an architectural perspective. I think it's also interesting to look at what this looks like from a process perspective. But before I get into the process perspective, one request. I'd ask that as you look at this with a process view, please look at it from the perspective of testing version 3.4 of your app, or version 73 as Chrome is now up to, or version 214 as the iOS Facebook app is now up to, rather than looking at it from the perspective of version 1, or even worse, sort of version 0.1, the first sprint of version 1. Customer-driven testing certainly can be used on these early stage versions of your app, but version 1's really an increasingly niche case in the world of continuous delivery. I mean, version 1 probably only lasts like a day or at most a week in production for most teams, but still most people are optimizing their test strategies all around version 1, and that's crazy. So please, as we talk about this process view, think version 3.4, not version 1.0. So let's look at how you do validate version 3.4 of an application using customer-driven testing. And the process is really simple. The first thing you do is you update the model based on the specification of 3.4. So the user journeys, the mock-ups, whatever it is that tells you how the way a user interacts, or maybe how your API works, or how the database scheme is laid out, apply those changes into the model. Some of you may have been wondering on my previous slide, look, where the specification's got to be there somewhere. Where is it? And there, it's in the model. This means that the model can now automatically generate user journeys that use the new functionality. And as you'll see in a minute or two, this is a super easy and quick process. Firstly, because there's one model for the whole application. It's not a model per test case or group of test cases. There's one model for the whole application. So any change only has to be made once, not in hundreds of places like today. We basically do automatic impact analysis without you even having to know about it. And the second reason it's quick and easy is because modern technologies like AI mean we can actually do a lot of the heavy lifting of maintenance work automatically. By the way, I'd also say that because models can easily be understood by non-developers and different roles, and they're just very quick to absorb, updating the model is an excellent opportunity for subject matter experts, testers, developers, BAs, and other folks to collaborate and get a shared understanding of the product and the users. Testers are always saying, look, if we could get involved in the development process earlier, this could be a lot more effective. Models are a great way of achieving that. The second step is you take any specific information about what success and failure look like, and you give that to the validation engine. And then step 3, you start executing. So the model starts generating and executing user journeys against the product. While that's happening, the selection engine is gathering information and determining which user journey to execute next. It gathers information from Jira about the software development process, from Git about the code base. It looks at the application itself and the results of the testing done so far, and it looks for risks. And it knows what the risk patterns are for this application from looking back at all the previous versions and what caused issues in them. You know, a lot of what's going on here is just taking all that data we have from testing, from development, and really using it to guide our testing. Something that's just really hard to do manually, but with the modern technologies we have, it's very, very easy. So it takes all this information from the software development process, also from production about what users are doing, what's important, and decides what journey to execute next. The validation engine then uses the explicit information provided in step 2 by the tester, plus everything it's learned from previous versions about how the technical behaviors of the product impact the customer experience and business outcomes, to decide whether what's going on is a warning or an error or all fine and all that kind of stuff. And step 4, ideally you have an experienced tester, someone who understands the customers, understands the risks, the kind of person who's doing manual exploratory testing today, and you get them to monitor and guide the execution. So if it sees the execution going into less interesting areas, or maybe not doing the use cases that it expect to, changing the weights of the different risks, or changing the weights of the patterns, or adding new failure patterns, setting the thresholds for usability errors, all that kind of thing. Really, rather than kind of just getting stuck in and doing all the testing, kind of pulling the levers and guiding the algorithms. And that's the process. By the way, I have always been talking so far about customer-driven testing as a way of addressing the customer experience gap in testing. And that is where it can do things that no other automation approach can. But when you see how little effort it is to update the model, it's for a whole big new release, it's probably a few hours. People often ask if it can also address that speed gap for the more traditional testing, for sort of regression and maybe new feature structured testing too. Because that Gartner survey I mentioned earlier, the 86% and 18%, also reported that 89% of teams are struggling to keep up with the pace of DevOps and continuous delivery. And the answer is, of course, yes, because specification-driven regression testing is really just a subset of full customer experience testing. So let's say we've updated the model for version 3.4 of our app, and we want to do specification-driven regression testing rather than full kind of CX testing. All we need to do is tell the selection engine to focus on the user journeys impacted by the changes, and probably some sort of specific key smoke test user journeys as well, and something around coverage. We probably do want to tell the selection engine to get some sort of coverage metric, say 100% pairwise coverage, so you could build that into the selection engine. And we tell the validation engine just to focus on verifying compliance with the specification and not worrying about other CX issues. And if we configure the system in this way and run it, we'll get traditional specification-driven regression and new feature testing, but just much faster than traditional automation approaches, really able to keep up with DevOps and continuous delivery. So that's great. It's probably starting to feel a bit theoretical, a bit abstract, and I think it's helpful to sort of start seeing what some of this looks like in practice. So let's jump into a bit of practical detail and examples to make it all real. So I'll start with this model because the model really sits at the center of this approach. And here on the screen, we have an example of a model generating user journeys through the Citi mobile banking application. So what's happening here? So what's on the screen in the middle is a model of how a user interacts with the app. By the way, it could easily be a model of an API auto-generated from a WSDL file. It could be a class interface. It could be a protocol definition. There's nothing really UI specific about anything I'm talking about here. It's just that for a presentation, UIs are obviously a lot more visual and a lot more intuitive. So that's what I'm using. In this model, the large blue boxes represent screens. So we've got the login screen, the payments page, the accounts page, the auto pay page, and so on. And the gray boxes within those blue boxes are the actions that a user can perform on that screen. So on the login screen, you've got enter username, enter password, click sign on. On the payments page, you've got sort of higher level actions like make payment, manage auto pay, see my payment history, and so on. So that's the model. And what you're seeing is the engine auto-generating user journeys through that model and executing them on the mobile app. Now, it's really important to note that this model here is not a flowchart, right? People see blobs and arrows and they think it's a flowchart. But this model does not define in any way the sequence of actions that we want to perform. It doesn't say enter username, enter password, click login. You can do that in any sequence it wants. The arrows on this page only indicate when an action leads to a new screen, or when there's a pop-up or sort of some really physically dependent action like that. It's not defining what the sequence of actions we think a user should do. It's all dynamically generated. And that's really important because that's what means that unlike normal test automation, a single model can generate and execute user journeys that have never been tested before, which if we're trying to emulate exploratory testing is really critical. I mean, this model on your screen here, I think that can generate about 22 billion different user journeys. I once calculated that it'd take 100,000 years to run, And so you know there's definitely quite a lot of test cases that this could generate and execute that have not been run yet. So that gives you a bit of a feeling for how this is running, but what's really going on under the hood? How's this working? How are we going from this relatively high level model that says, you know, show me the payment history, to actual specific buttons being pressed and text being typed on a real device? Well, as I'm sure you'll appreciate, that's quite complex, and I actually don't have time to go into it today, and I don't want to get too much into the specifics of the product, but I do have another talk that's on our website where I do go into how this all works under the hood and how you use neural networks and learning algorithms and so on to really build up this automated model. So if you're interested, please go to our website and check that out. But a few things I would like to highlight about this sort of model approach. The first is what I said before. The model can generate and execute user journeys that have never been run before. Now, I mean, that's really a key principle and really unlocks this idea of an automated approach being able to emulate some element of exploratory testing. That's really critical. The second point is that this is one model for the whole application. We don't have models for different features or different test cases. It means that when we want to update the model, say because we've added some new functionality, we only have to make the updates in one place, and that makes updates quick and reliable. I mean, the approach, again, it just removes that need for impact analysis. You can have sort of submodels and so on, so when you've got a very complex application, you know, it's the maintenance of the model scales, so you can do that, but still you're defining everything once. It's a key principle. And finally, as I said before, the creation and maintenance of this model can actually be largely automated. It definitely needs some guidance and hints from a tester, and the more non-standard your application is, the more that's going to be. But in most cases, the vast majority of the work to create and maintain models can be automated. Again, that's a big topic on how that all works. I do cover it again in more detail in my other talk, but I just wanted to highlight it here. So, in summary, we have a high-level model of the app that can generate and execute user journeys through that app, which is pretty cool. So now we can auto-generate and execute user journeys, which is wonderful. And I remember when we first got a prototype of this working about 2 years ago, we were working on the Amazon shopping mobile app, and this is a model on the screen. And it may look quite small, but again, including data, you can actually generate 9.2 billion different user journeys from this app, which of course we thought was great. I mean, this was microseconds to create a new test case, which would normally take a team maybe like an hour to automate. But then of course we looked at, okay, but we can't run 9.2 billion tests overnight. We certainly can't run them on every check-in. We can probably run a few thousand overnight, and we maybe run tens and hundreds on every check-in. So of those 9.2 billion, which test should we run? And it's a really good question. And at first we didn't have the answer. Of course, there are existing approaches to test optimization, risk-based testing, equivalence classes, things you'll be familiar with. But those approaches really just don't even begin to scale up to billions of tests. And actually, they're pretty questionable in terms of finding defects. If you ever look into sort of the black swan theories of where defects really come from, especially the nasty defects, and how that relates to equivalence classes, it raises a lot of questions. So we need a new approach to deciding which tests, which user journeys we're going to run. Something more intelligent that can emulate how a good manual exploratory tester works, because that does seem to work. And again, this is where AI helps us transform testing. Because it's appropriate that we're speaking about Amazon, because the core concept is to create a recommendation engine using neural networks to decide which user journey, which test we're going to run next. So how does a recommendation engine work for those of you who haven't gone into it before? Okay, well, let's start with sort of the standard example of books. Let's say you've got a set of books. The recommendation engine gathers a bunch of attributes about the books, about each book, such as the author, the genre, the length of the book, year published, all kinds of information. It then uses a neural network to look at the books that you've previously bought or shown interest in to understand what you like and dislike. Again, We don't have time to go into it, but basically what neural networks do is understand the relationship between inputs and outputs. In this case, understand the relationship between the attributes of a book and if you're likely to buy it. So it understands that relationship. Once it understands that relationship, it can look at all the remaining books, work out which one you're most likely to like or dislike, and that's the one it recommends to you. Okay, what does that look like for testing? How can we use recommendation engine technology to choose the next best user journey to execute and create our test selection engine? Because we're interested in test cases, not books. Well, so in testing, the books just become user journeys or test cases. The attributes of those test cases are all the information we spoke about earlier, risk variables from the software development process and the code base, such as whether this user journey has been impacted by a recent code change, the underlying technology stack, who made the change, when the change was made, and so on. It includes risk variables from the product design itself, such as if it involves very busy screens, whether it's making database transactions, whether it's going back and forward in the control flow. It looks at the results from testing so far. It looks at information from production about which user journeys users are really executing, which ones lead to conversions, i.e. the ones that really matter. And of course, it also looks at hints from an experienced tester guiding the process. So it takes a huge amount of information, quite frankly, the amount of information that a human certainly can't absorb in an analytical way, but actually good manual exploratory testers can absorb and use through intuition. But of course, that takes a very long time to build up, which is why it's hard to scale. And of course, what we're looking to find here is not which book we should recommend. We're trying to find which test case we should run next. So just like for books, we use a neural network to look at the history and work out the patterns of attributes that are most likely to find a high impact customer experience issue. For example, maybe it's user journeys that involve Bluetooth, maybe it's user journeys that involve a lot of C++ code, maybe it's user journeys that involve components from different teams interacting, maybe it's a weird combination of these factors, which is really hard for a human, but a neural network can work out these patterns. And the test selection engine then uses this information to select the user journey that's most likely to find a high impact customer experience issue. And that's how the test selection engine works. Essentially, it's using a neural network to do highly sophisticated risk-based testing analysis in a structured way, and then a knowledge-based recommendation engine to select the user journey to execute. Fundamentally, it really is emulating how a manual exploratory tester works. It's just using an artificial brain guided by a human rather than only using the human brain. Cool. The third part of the customer-driven testing approach is the validation engine, which, as I introduced earlier, does all the basic and specification-driven validations as well. That's the easy bit. But much more interestingly, it also determines how the technical aspects of the product, functionality, performance, and usability impact customer experience and conversions. And it uses this to define failures. So how does this work? Well, again, we're using AI to understand the relationship between data. But this time we're understanding the relationship between technical behaviors of the product, so functionality, performance, usability, things we can directly measure when looking at the product, and business outcomes, what user journeys people do, whether they buy, how quickly they do things. We can then use this information to automatically generate customer experience validations as we execute user journeys through the application. For example, we might determine that if the page load speed of a particular page goes over 2.4 seconds, 10% of people abandon the app, so it's a CX failure. We might determine that if we have more than 5 text input fields on a particular page, that slows people down, and so that's a CX failure. Or maybe it doesn't slow them down, maybe it just makes them unhappy. It's a CX failure. So again, we're using AI to understand the relationship between technical behaviors and users, and then using that information to determine whether a test passes or fails. And of course, again, we expect that an experienced tester is guiding the validation engine. And I think this is really interesting. I think a lot of people I've been talking to recently have been wondering, in future, how are we going to define what failure looks like. At the moment, we have these golden oracles, which we can define statically ahead of time. But as systems become more dynamic, more complex, they have AI within them, which can just change the behavior. You get emergent behaviors. How are we going to define what failure and success look like? We can't do that statically and manually. And I think here is the beginnings of the approach. So what does this actually look like? Well, here's an example from a retail website called Cook. For those of you who don't know, Cook is a food retailer with about 450 stores around the UK. So here we're analyzing a bunch of information from the website. It's a mix of technical behaviors such as page load time and conversion data such as bounce rate, purchases, and revenue. Now, obviously what you're seeing on your screen is quite a simple view so that it's actually visible. I think we're only tracking 5 or 6 metrics on the screen, but in reality we're gathering hundreds of different variables and understanding the relationships. We're then using this information to construct a model of how the page load time impacts revenue. And in this case, rather than feeding that information back into a testing model, for simplicity we're just manually running a bunch of scenarios to determine how changing the page load time of particular pages would impact revenue. And for example, here we've determined that reducing the page load time of the checkout screen from 2.78 seconds to 1.5 seconds would generate an extra £39,000 per week. And of course, we did implement that recommendation and it did achieve that, which is exciting. So again, we're using AI to understand how technical behaviors impact users and then using that information to determine whether a test passes or fails. So that's it. I hope you found this presentation interesting and helpful. The key messages I'd really like you to take away are, first, customer experience is absolutely critical in the world of digital business and continuous delivery. And if test is going to remain relevant, it's got to put CX at the center of the testing strategy. But most of us today don't know how to create a great CX. Only 18% of people do. They do that mainly through manual exploratory testing. And the third point is customer-driven testing is a new approach that is essentially emulating manual exploratory testing to help it scale up and go faster. Customer-driven testing can also accelerate more traditional specification-driven testing, but as I've said many times, human creativity is still needed to guide the process. It's all about augmenting people with great technology. As Eric Siegel said, strategies designed in part by human creativity succeed. And I think that's a great place to end. Thank you very much.